Hey everyone, my name is Salim Haniff. Today I'm going to talk about how to use Ansible to set up VLANs and firewall policies on the Fortinet appliance. So this is a first of four in the lecture series that I'll be doing, and in this lecture series I'll go over how to set up the Ansible on a workstation to help us launch Ansible playbooks towards the Fortinet appliance. And I'll introduce you to some of the Ansible playbooks that you can use to help set up the Fortigate 60D. So a quick background. Many organizations tend to split their networks into segments, and this is to help enforce security policies. For DevOps-enabled organizations, they tend to have a dev stage prod environment, and this is also to help ensure QA/QC policies. With a dev environment, your applications tend to be more log verbose to help you troubleshoot what's going on in your application in terms if you have any difficulties in seeing what's going on with the application. Dev environments tend to also be experimental, so you might want to use an experimental technology and you don't want to risk having any security holes. Whereas in production environments, you want to isolate and not have too many logs being exposed to the public. That's to prevent any adversaries or malicious users finding out what's going on with the application, finding holes in that application, and somehow hacking that application to create data leaks or perform functions that they're not supposed to. So each environment has different set of security policies that need to be applied, and VLAN and using VLAN with firewall policies will help with some of these issues. So why do we want to use Ansible? The industry has moved towards an infrastructure as code paradigm, and by using infrastructure as code, this helps to maintain a consistent state of the environment. Ansible playbooks are declarative by nature, which means that they will enforce a policy on certain devices. Code itself, in particular, acts as a single source of truth. You're always editing one instance of the code, and you're trying to force all your policies in this code. So anybody can, with the proper authority and authorization, can view this code to see what is taking place in the environment. With this code, you want to combine it with the source control management system, like Git, for example. So anytime you make changes to the code, you will commit those changes to the repository, and then you can audit who's been making changes to the code. And in the event that a code has been pushed out to these routers and something has gone wrong, you could always revert back to to a version that you know that works and push that old version out to the switches. We also like to use Ansible because it helps to automate manual tasks. You don't need to keep going onto the web UI, clicking various widgets and putting configurations in, and you don't want to always use a CLI interface to log in to switches to manual type in tasks to enforce policies. So why did we choose Fortinet? Well, Fortinet provides Ansible modules, and I'll take you to take a look at one of these modules. So this module helps to set up IPv4 policies, and if we scroll down, we'll see that for running this task, we will need to fill in these parameters, and we can scroll down to the bottom and we will see an example. I'm not going to go into too much detail about this right now because we will be using a Ansible playbook, and I'll show you how to actually put these rules into the playbook and then execute that. Another benefit of using Fortinet is the cookbooks they offer the customers, and I'll open that up as well. So this cookbook illustrates an example of how to use VLANs to help set up a network. So we'll scroll down here, and in this example, we're going to convert this cookbook into an Ansible playbook. And For this example specific, we're not going to be using the Cisco 2950 switch. Instead, I will have two CentOS servers connected to the router directly. If we scroll down, we will see that these are the commands you would type on the CLI to help configure a VLAN 100 and a VLAN 200. What we want to do is we want to use Ansible to do this instead of having to log on to the actual switches or routers to do this. So the first thing we need to do is we need to set up our workstation. Ansible by nature is written in Python. And what we would like to do is use the virtual end feature of Python to help create a consistent Ansible environment. This is crucial in many organizations because you want to keep a level of consistency throughout the environment. And one of the problems that face some organizations is version controls of various packages. If you've used NPM or other package managers, you'll notice that they'll have a way of version locking various packages. We would like to enforce this version locking concept with our environment as well. So what we'll do is we'll quickly run through this set of commands to help build up our environment. So here's a simple shell that we have on our system, and I'll just create a simple directory. We'll go into this directory and we will create a virtual environment. We'll go into this environment and then we'll activate the environment. All right. So as I mentioned before, we like to version lock all the packages that we're using, and what we will use is a requirements text file that's commonly used when you install Python applications. Sorry about the text, it doesn't seem to be formatted well here, but we can go to the GitHub repository. And we will download this requirement text file. Just 1 second. So I'll quickly take a look at the requirements. So one of the things with Ansible and with the Fortinet in specific is we will be using the FortiS API that's provided by Fortinet, and we'll also need to use this request. When we run the Ansible playbooks for Fortinet, it tries to create a local connection back to your workstation, and then it uses the request to use the REST API feature offered on the Fortigate appliance. So we'll go back here and we'll see that it's still downloading and installing our packages. And we'll wait till that finishes. And in the meantime, Okay. Now that it's completed the installation of Ansible, we're going to create an Ansible directory. And go into that directory. And we're going to grab 2 more playbooks. So if you go to the repository, under the 1 directory, we will have 2 playbooks. We have one for creating the VLAN, which you can see right here. So we'll grab this. And we'll grab another playbook that will remove our VLANs. Okay. So I'm going to switch over to VS Code now. And we're going to view the VLAN. So this is what a Ansible playbook will look like. So we have a bunch of variables up here that we would need to configure. So for Fortinet to talk to the appliance, we'll need the host IP, and in our example, our host IP is 192.168.50.1. We already have a user pre-configured on the Fortinet user Ansible. For best practices, do not put passwords in the Ansible playbooks. What we do is we use a feature called lookup password. So we actually store the actual password in a different file. So I'm going to open up a terminal here, and I'm going to copy over the password here. So as you see, we're going to create a system interface for the VLAN 100. And I'll just copy paste this to the browser. And you notice that we're going to be configuring the interface of the Fortinet appliance using this task. And if you scroll down, it's a really large set of parameters that you can set. And if we go down to the example, it's also a large set of parameters that can be set. However, one thing that I noticed, if you go to the cookbook and you take a look at the VLAN interface here, you'll see that the VDOM root interface and interface internal type VLAN ID is all consolidated into these parameters right here. You don't necessarily need to fill in all the parameters you see here. If you just go by the cookbooks provided by Fortinet, you can quickly see that you only need to set up these few functions, these parameters here. So that's what we see here. So here is VLAN 100, and VLAN 200 right here is right here in our Ansible playbook. And you'll notice that we need to set up some firewall addresses. So if you scroll down, you'll see the firewall addresses here. The same applies. You can go to the Ansible playbooks, and then you'll see this task and then the parameters here. Scroll down, and then you'll see how to fill them in. Again, this shows all the parameters you can set, but if you follow the cookbook, you see that you only need to set type and subnet. So if we go to our playbook, we have our type, subnet, and name there. So if we scroll down here, you'll see that we're setting up some firewall policies, and here are the 4 firewall policies in this cookbook. And if we look at our Ansible playbook, you'll see right here our firewall policies. And you'll see all the exact same information that's been used here. We just place it in here. So once we're happy that we've got our variables up here set, we can launch the playbook against our appliance. Before I do this, I just want to verify that if we go to here, we can already see that under network interfaces, we do not have any VLANs present at the moment. So I'm going to run the playbook right now. So occasionally when you run the Ansible playbook, you might encounter a timeout error that happens. Basically what's happening is trying to do a REST API call using the request module, and it's not working correctly. So to get past this, you just have to run it again. And now we'll refresh our page. And now you see after the playbook has been executed, we now have VLAN 100 and VLAN 200. I typically try to create an Ansible playbook to remove what changes I've made to the appliance. This is to help put the appliance back to a known state, or when I need to roll back a change that's happening. So for us, we'll need to change the host, and then to the user. And we'll repeat this again. And we'll go back and we'll double check. So now you've noticed that the VLAN 100 and VLAN 200 are now gone. So we'll rerun it again to re-add those VLAN 100 and VLAN 200. So that time we had a successful run all the way through. We didn't have any problems like before. All right. So if we refresh this, you'll see VLAN 100 and VLAN 200 have now been added. So now what we would like to do is we would like to test to make sure that we are able to ping each side. So what I'll do is I'll configure my laptop here under networks. I'm going to add a interface. I'm going to add a VLAN. I'm going to call this VLAN 100, and we're going to put the tag ID to 100, create this. Done. So you'll notice VLAN 100 is now here, so I'll select this, manually 10.1.100, 255.255.255.0, router 10.1.1.1, apply. And now I will turn off my interface connection to the Fortigate router directly and try to use the VLAN. And now I'll try to ping 10.1.1, and we have a successful ping. And now I'll try the other router. So now we know that our firewall rule is working. For fun, we're going to try to turn off the firewall rule just to see what happens. So right now we're pinging from VLAN 100 to VLAN 200. So I'm going to disable it under policies, IPv4 policy. And you notice because I disabled it, it won't work. So we'll have to go 10.1.1.1. Okay, I got to go over to new tab. So I'll log in as my user. I'll go down. And I will look for this policy right here. And I will deactivate this policy, and then you'll notice that the ping will eventually stop. And now I'll re-enable the policy. And now you see that we can now ping again. So in this tutorial, we went through setting up a workstation with Ansible to communicate with our Fortinet appliance. And we've provisioned 2 VLANs with firewall policies through the Ansible Playbook. In our next tutorial, we're going to add 2 CentOS servers to the network. Each will have their own different VLANs, and then we'll try to communicate with them. That wraps up this tutorial for today. If you have any questions or feedback, please reach me at my email address here or my contact information below. Thanks.